Wrong screen there. Yeah, so I am a bit less prepared than usual for this week. I've been out on vacation and had some exciting developments with a potential collaboration between Wolfram Alpha and RChain in providing oracles, maybe being live as like initial as the test net. So that's what I've been working on. But yeah, I wanted to start with just sort of going over the Rholang 0.2 spec and use that as sort of a jumping off point for us to talk about. What Rholang is compared to what the Rho calculus was, and yeah. But if anyone wants to jump in here, please feel free. So in my email, I noted that this document isn't really perfect. It's mostly here for historical reasons. And it's sort of the best explainer that we have right now in terms of, could I get people to mute if they're not talking, please? Thanks. But yeah, it's sort of the best explainer we have right now. Best like English language explanation of some of the Rholang syntax and some of the syntax that's not in Rholang right now, but is planning to be for the initial release. If you want to see sort of a stronger definition, you can look in GitHub under the context-free grammar files that are used by BNFC to actually like create the parser that the compiler uses. This is the path for it. There's the Rholang CF, and then there's also the Rholang Mercury CF. Rholang Mercury CF probably contains some productions that aren't sort of currently in the node but are planning to be in the node for the Mercury release, and also might have some bugs and have not have some things for definitions that the Rholang CF uses, because this is the one that's actually being tested. So yeah, I guess the I haven't spent a bunch of time with this file, so I sort of know how to read some of this, and I think I could make it most of the way through, but I'm not sure that I could explain all of it right now. But I think given what we've done in the previous sessions with the PyCalculus and Rholang explanation, the Rholang spec 0.2 should be pretty readable. And I think from that, that should get you closer to the syntax that's used in the context-free grammar. So has anyone looked at either of those two things or three documents and have any comments or questions?
Yeah, this is Kayvon. I had looked at the spec, but I hadn't looked at the grammar. That was kind of my ignorance that I didn't even go look at it. And I was wondering if at some point we could go from one document to the other as to how the spec is translating to the grammar.
Yeah, sure. We can look at that a little bit today.
So I also have a comment. When I'm trying to download the spec from the documentation page, I'm getting a 404 error.
Ooh, what page are you going from?
Developer RChain co-op/documentation. Oh, it just worked this time. That's weird. I like literally just did it twice and it gave me a 404 and now.
Okay.
So, all right.
Funny.
Scratch that.
Roland, did you have a question as well or something to say?
Oh yes, hi Jake, and hi everybody. I'm new to the group. I have read the spec and I was wondering about the social contract rhetoric. Do you think this is still a residual from Cinero, or is something that is crucial now also for R-Chain?
So you're talking about examples.
Right in the title, it says already a social contract language. And then eventually at the end, it also says, yeah, we want to build first a social platform because it's so important, blah, blah, blah. And so I'm wondering if this is still scenario or they are still sticking somehow with the strategy and it's still important.
Yeah, so I don't know much about, I mean, I know that R-Chain project has its roots in scenario. You know, I don't think that, you know, the goal is still like first and foremost that a social network application is driving the development of this platform. I think the development of the platform itself is sort of the first and foremost priority. But yeah, I think you know, Greg and a lot of others really do see, you know, this new calculus of communicating systems as being able to better interact, better model sort of human interaction processes, you know, where we each sort of have these independent agents that are communicating with each other, and that if we can model those processes, you know, we might be able to express, yeah, essentially have it be easier to express those types of processes in code. Yeah, so does that answer your question?
Yeah, thank you.
Okay. Okay, so let's just get rolling into this document then. I'm going to start down here with the syntax stuff, looking more at the mathy type language than the exposition in this document for today. So here they give, at first they give an introduction to the real calculus syntax, and this should be pretty familiar given last week's session. There's a couple of things that are a bit different. We have this input guarded agent that is, instead of having like a single input where before we had like, in this case, it would be y1 and then in parentheses x1. For our input now we have sort of, we can chain multiple of these together. The syntax of it looks a bit different. It looks kind of like a Scala for comprehension. But what this means is that if all of these inputs here can happen, which it's listening on the channel y1, y2, y3, all the way up to yn, and is going to take whatever it receives and bind it to the names x1 through xn. And if all of those inputs are available, they can come in different order, they can come in from different processes, then process P will run with those substitutions. Then we have the output, looks pretty similar. We introduce this exclamation mark. We still have the stop process being 0. We do reintroduce this summation or choice notation, meaning you know, one run, if all of these things are listening or receiving one of these, or listening or sending, one of these can happen, and then the rest get deleted once one communication happens. So those are all the definitions for the normal processes, and then we can dereference or turn a name into a process. We can compose things in parallel. We can turn a process into a name with the @ symbol. So the @ symbol and the star symbol are being used for the quote and dequote instead of the like angle brackets around the names. Free name definition is exactly the same as before. You know, when we're listening for stuff, our free names are the names that we're listening on, and our bound names are the names that we're receiving the input to. Yeah, I guess this is the one that we didn't have explicitly before, but the free names in m plus n are the free names in n plus the free names in n. Any question about that? I guess we'll go over the structural equivalence. And
Do they still have choice now? Because in the documentation they didn't have choice on developer.
where didn't they have choice?
When you go from developer into our chain platform architecture, and they describe the syntax under contracts.
Yeah. So I think when we get a little bit further, let's actually see if there's like a select or a branch here. Yeah. So there is still choice happening behind the scenes somewhere. I think the architecture document, to my knowledge, is a bit more outdated. I think that's like about a year old, and I think this document, this O.2 spec, is a little bit newer, and then the grammar files are newer still. So yeah, that's sort of the order of precedence there, I think. Don't quote me on it though. Yeah, so then we have structural equivalence is defined the same way, and we have this name equivalence helping define structural equivalence as before in the row calculus. Yep, and then that distinction between the syntactic versus semantic substitution. The substitution is used for alpha equivalence versus the substitution that's used to like run a process or an unquote. Okay, and then the reduction relation is actually wrong in this document. Yeah, and Glenn, select is the same as choice, I think. We'll see that when we get to choice later. Or select later. Let me share. I'm gonna just share my whole screen here. All right, can everyone see this? Yes, no? Yeah, okay, great. So the COM rule here is the same in that an input is meeting an output. It looks a bit bigger here for reasons that I guess we'll get to. So we require in here xi and xi prime are given as two name equivalent names. This is just to show that a reduction can happen with name equivalence and doesn't necessarily need the same name. Well, yeah, I guess it's has your definition of same name, but so we have here a process that consists of 3 summation parts. So it's a choice of either R or this input or S, and the input is listening for multiple inputs on Y of n. Will bind what it receives to the xn's. And in parallel, if in parallel, we also have all of inputs available at all of the y's. So this is saying we have this process here being sent on something that is name equivalent to y1 all the way up to yn. Then if we have those 2 processes in parallel, then this R and S will be removed because only this middle one takes place. And so P runs with all of these substitutions.
Is there priority to the different possible reductions so that communication would take a precedent over R or S happening?
No, there is not any preference associated to races. So yeah, when you're
R could happen.
R could happen. Yeah. Mm-hmm. Yep. This is a possible reduction. There could be other possible reductions as well. Yeah. But yeah, but other reductions will have a similar form. All right, so I guess that's an overview of the row calculus. What questions do you have about the row calculus presented here? All right, we'll move on to the syntax then. So since the syntax here, I think isn't the most up-to-date version and has some issues with it, I think the main value of going through this is sort of realizing the types of constructions and new things that we're at least thinking about adding to Rholang that should make programming in Rholang easier. And this should just give you a good flavor. Don't take this as sort of the truth of what the final syntax or constructions are going to be. So the way to read this is, this is the entity that we're constructing on the left-hand side here, and then this is giving us a whole bunch of exclusive ways that we can construct that entity. So the first process, right, is this using the string nil is the nil process. And then there's we can group processes together with these curly braces, and that gives us a new process. Let's see, let's kind of use these next to each other here. So I made some quick examples. So I guess let's go through. I think I put the sends in there first. So looking at this construction here, we have a name, and whatever this send. Whatever we use to denote a name, whatever we use to denote a send, and then a list of processes. So this is sort of a definition that has other definitions embedded into it. So if we look at what send is, we see that it's either a single exclamation mark or a double exclamation mark. And in this case, the single exclamation mark is meant to mean a send that only happens once. And then the double exclamation mark means a persistent send. So a send that when it gets consumed, stays in the store and is ready for another process to consume it. Was there a question there or comment? Yeah, so the way that this would look is, you'd have this single bang and then sending multiple processes, or the double bang sending multiple processes. And then there's also this like contract invocation style of a send, which just takes a name and then without the bang, the processes after it. And the idea is that potentially in the future, the difference, the semantic difference here, or the syntactic difference here, would denote who is intending to pay for the, or who is willing to pay for the transaction that happens on the chain. So in the case of, in the case of like a contract invocation, this would pair up with the input contract syntax that's down here. And would indicate that the invoker, the send process, is willing to pay. Whereas with the exclamation mark here, it pairs up with one of these fors and indicates that the for is willing to pay for that communication to happen. So you can think of it, I think we've been calling the receiver pays model as a like data feed. So if you wanted to provide like a data feed that that people have to pay to get access to, that would be a way that you might do that. Now let's pop up to the top here. Is the syntax here making sense to people, or what questions do you have about the way that these sort of constructions are presented? I guess there's also these stars, which means repeat this, I guess, one or many times in this case. And then there's these brackets, which means that they're optional.
On the sent process list,
yeah,
is the sent going through the list sequentially, or is it parallel?
That's a good question. That's a good question. It is okay. So it is in parallel, and it will. Yeah. So that both sends and receives that are introduced now have like an arity, have a number of parameters associated with them, and I don't remember what we decided, but it was either that sends and receives of the same arity would match up, or if there was like a larger arity in the send, that it would sort of, the last argument in the receive would get bound to the list of those processes, which is itself a process.
So the different outputs are at least bound together. They won't be non-deterministic with who is receiving them one by one?
Yes. Yep.
Okay.
Yep. They're all bundled together.
Okay.
Okay, so now I guess we'll go through the input constructions. So we have the receives with this arrow in the middle, and this is a one-time for. So this means that this is a listener that will only execute once, move on to P, and then it will be consumed. It will be deleted. And then there's a persistent for that uses this double pipe here, this equal sign. And that means that is going to continually listen on the same name. And essentially once P is spun off and runs, it places, it's a replication. It places a copy of itself in the tuple space. And then the contract syntax is just sort of another way to write this persistent for without the payment semantic difference that might happen. These are pretty much the exact same construction. Then there's this receive and then send way to listen on a name. So it might be necessary for you to write a process that only checks a value at a given channel, and you don't really want to consume it. This is just shorthand for read from the name, and then output the same content that you just read on the same name. I don't know what this is. There is this double arrow, which is meant to be sequential. So you must receive on this Y1 before you receive on the Y2. I'm still a bit fuzzy on, yeah, I haven't seen any examples use this, and I haven't seen it implemented yet, so I'm not really sure what that's intending to do, but the specifics of how it works. But the idea would be that you could sort of serialize your inputs somehow. and there's this input filtering construct. So if you want to receive a value and then, or if you want to only receive a value if it matches a certain pattern, you can do sort of like this construction here, if, and then all of this would be a Boolean process, a process that evaluates to a true or false value. So yeah, that'd be a way to filter your input. Yep.
Is that, how is that different from the pattern matching built in to the, well, here you've been writing X1 instead of P1. Are we looking at the pattern matching right now?
Yeah, so this isn't, so you could use pattern matching to construct a Boolean process. I guess what we're looking at right now, let me find this construction over in the other file. Input filtering. Yeah, what we're looking at is this for receipt process. And then receipt has this lin receipt, non, and so this has, right, this has like the names, arrow, other names. This is the stuff that's sort of inside all of our for loops. And then we have this if clause. The if clause is if and then another process, but the syntax allows the process, but the compiler complains if the process is not a Boolean. And then the match, which I think we're getting to next. There's a select, which is also, let's just go over a select quick and then we'll go to matching. So yeah?
A question about received and sent. You cannot have an ulterior continuation there. So what do you think is the purpose of having that?
Oh, where was the received and sent? What was that? Okay, so none are. Not letting me see, sorry. Just trying to find the construction. This isn't the easiest thing to read. Oh yeah, so I just didn't include it here. So this can't have a process after it. Does that answer your question?
Okay, thank you.
Yeah. Okay, so then there's these select statements, which is the choice or the branch. So here you have on the left hand side, you have many inputs that you're saying could happen. So I'm saying I could receive from Y1 and Y2 in the case that Y1 and Y2 have a certain value associated with them, have a filtering clause, and then P could happen, or I could just receive on Y1 and have a certain value Q happen, and these two lines are mutually exclusive because in up here I'm only triggering if what gets received on Y1 is greater than 0, where here I'm only triggering if what gets received on Y1 is less than 0. And I guess it's not what does get received, because before the pattern match happens. Oh, no, I think Brenna has them. sorry. Yeah, so these two options are mutually exclusive. And then, so yeah, either one of these would happen. And then here's an example here where I'm just taking whatever is received on Y1. So these options are not mutually exclusive. So this would just indicate like this is like if we have a plus where we have a receive listening on the same name in two of our different summands, and it would just be non-deterministic which one gets chosen. But only one of these, only P, Q, or Z would run.
So it doesn't look at those cases in the order they're specified. It's a little different than like a switch case where only if the first one fails, it goes to the next one. It's just going to do, if more than one matches, it's non-deterministic.
Yeah, exactly.
Okay, cool. Thanks. I didn't know that.
Yeah, at least as it's being talked about right now. I don't know if that will change in the future. But yeah, I think that is just supposed to be like the way to create like an input guarded summand from the RoCalc into the Rholang. Okay, so then, yeah. So we have matching, which can create a process, and the process that comes out of this. Oh, I guess it doesn't have to actually. Okay, so yeah, it can create a Boolean process. It doesn't always create a Boolean process, this the match keyword, because there's different types of matching. So P matches Q will create a Boolean process because that evaluates to either true or false. So with the match, we take another process construction here, and that process construction can have free names in it, can have like variables essentially in it. Oh yeah, sorry. So this is just any process, yeah, that we've constructed. And then our cases down here is where interesting stuff happens. So this would be saying if our process P matches this format here, so it matches a singular send, then we'll execute process Q. And in process Q here, we have the actual names that were used in this process P in X and Y available they're bound in Q, so we can use them and reference them, and then whatever came in on P will be substituted for X and Y. So if P here was like, Z, Q, then X in process Q would be referred to as Z, and so those substitutions would take place. And then, yeah, this is just an example, so you can do the same thing for input or any other process there. And I think this one does behave like a switch statement in that these are executed in order. So there is a general case which would just match anything.
So if they go in order, that general one should probably go last, right? Because otherwise they...
Yep.
Okay.
Yep, so that would mean that this one would never execute.
Got it.
Yep. So yeah, then we have this P matches Q, which is just a desugaring. Yeah, that just, if it matches that process construction, it goes to true, otherwise false. New names defined by just writing the word new and then names, and then in a process declares the like scope of those new names that when in the process that you're writing. And then there's a whole bunch of these different ground types, which are kind of cool. These are processes that are equivalent in semantics. So they behave the same as the null process, but they have some structure to them that can be useful to our program. So we can have we can think of two ground types as the Boolean values, true or false, or different integers, or a string, hello world, or a date time, or a list of processes, or a tuple of processes, or a set of processes. Another thing that we can do with these is we can define methods on these ground processes. So this is how you would do like string manipulation and that sort of thing. Here's an example of having a list process, and then if we've defined get item 0, you can maybe get the 0th item in that list. So that's going to be a way to sort of expose some of the underlying Scala data types and their methods to Rholang through the node. And then what do I have down here? I don't remember what this is. Oh yeah, that was just something that I was copying over to. Yeah, that's nothing. Yeah, so that I think gives a good overview. There's also these binary operations on processes that produce other like Boolean processes, or can manipulate Boolean processes. Yeah. So I think that's really probably a good overview of this document. What questions do you have? And then we can maybe flip over to the grammar for a bit and find a construction and compare the two. There's something in the chat. Let me see.
On the terminal screen, can we go over that desugaring example that you had?
Which one?
So, yeah, right there. Exactly. So, what I'm not clear as to on the for part. So, y1 is bound to x1, and then the continuation p is executed. And we're saying that, I guess somewhere in p, in that continuation, we send a message back to x1. Is that what?
No. So I guess the desugaring here is we put the value received at x1 back onto y1, and we run p in parallel.
Okay.
Yeah.
Okay. So x1 is the channel. X1 is a channel name here, right? Is it also a process? Is that why you need to dereference it?
Yeah. So we send processes and receive names. That stays the same from the row calculus. So here we're receiving on y1 something that's bound to this identifier x1, and so that something is going to be a name, and we need to turn it into a process in order to send it across the channel. The other way that I could do this is that. So this can actually be a pattern here, the same types of patterns that are used in matching. So this means that y1, if it is a name which is being sent, is a name which is being received, which is always a name that's being received, then it takes this x1 now refers to the process that's inside of that name.
Okay, so in the previous example that you had, or the previous way that it looked, this would imply that x1 is a process, right? Like, I'm trying to get some intuition for this.
X1 is a name here. Now, all of that is a process.
Yes, but when you put the @ sign next to x1, in that case, x1 could be anything. It could be a string. It's not a process anymore, or it cannot be a process.
So strings are processes.
Okay, yeah, that's true.
It's always going to be a process.
It's always going to be a process.
Yeah,
okay.
Right. There's two types of things: names and processes, and they must strictly alternate. Right. You can't quote a quote, and you can't unquote an unquote. So assuming that x1 is a name here, does the name always have to be new first? Like I have to say new and then the name, or to use it? No, it doesn't. You don't have to. The compiler is going to complain if not all of your names get bound somewhere. So yeah, you probably want to new it, but there's going to be this notion of public names as well that sort of are URI looking things. And so these are just names that you could just type out and you don't have to new to communicate in a specific way with a specific entity. So in that case, those names don't have to be newed.
Okay, thank you.
So the names can have free variables, and in that sense, when you're receiving something of that form, you're looking for anything such that that equals that form substituted in some values, and that's how you have pattern matching along channels?
Yeah.
Okay. How does that work? How is it checking like that it fits that form with the free variables and trying like substitutions?
Yeah, so it's yeah, I am not exactly sure. So I know that that when Kyle wrote the matcher and the parser, they're essentially the same code. It's just that so the when the parser is looking through Rholang code to compile it, it can see these. It doesn't distinguish between like Rholang code that has these holes or these variables in them, and ones that are bound, and then it sort of does that check afterwards. So it's parsing the program sort of in the same way that the parser right now parses the program. Does that answer your question? And I don't know all the details. I think Kyle could probably talk about that in a lot more detail than I can.
Yeah, I think so.
Yeah. My intention is to go look at the matcher code at some point because, yeah, it sounds pretty cool. But I haven't had time to do that. Okay, we're coming up at the end here. So if anyone has any comments or questions, also next week, not planning to do a session, just sort of have an open discussion unless someone wants to take the lead on that. It's the weekend of my sister's wedding, so I have a whole bunch of family in town and stuff and don't have really a lot of time to prepare next week. Yeah, but otherwise let's go and look at the grammar quickly here. So so let's pick something. What would be a good thing to pick? So yeah, I guess at the top here, right, so these are all the process constructions. We can see that that one of them is the nil process, the same as before. And there's this like drop operator that takes a channel or a name, has this star in front of it, creates a process. And then I think you can see, nope. Okay, so I think that must be just a label. That's just a label. Proc3 then. Yeah, I don't know why it's broken up like this with a whole bunch of different process levels. I think it's probably to, I think it's probably to sort of give the order of operations precedence to all of these different constructions. Yeah, so this is just a label here, and then we have another label. So we can have like both qneg and qeq are both these quantity one types, and these are defined by quantity one not equal quantity two, quantity one equal quantity two, and so these quantity ones and quantity twos. They are essentially just different constructions that allow you to do like order of precedence operations. So if you look at like a introduction to Lex, you'll understand why that is necessary. I'm not sure that I can explain it right now, but yeah, so this is just like two ways to say that quantity one, right? The equal operator and the not equal operator should sort of have the same order of operations precedence. Yeah. Does that help? Is that, you think the CF is readable with a little bit of work given the definitions that we were sort of looking at with the Rholang spec here? It's sort of the same in that we have these like these embedded definitions in definitions. And so if you want to really see everything, if I wanted to see for this choice, the complete syntax, I know we have the select and then these parentheses, curly braces with some stuff in it, but I need to know what's in the middle. So I need to look up what the C branch definition is. And it's an optional. And so this actually has this is the case. And then whatever that bind is, it's going to be that pattern matching thing. Double arrow and our process.
What does CF stand for?
Context free. So this is like a context free grammar file.
Got it.
Cool. So in the future, the work that's going to be done on the specification is going to be done in K framework, and that will hopefully provide a much better specification to read, look at, and also like understand technically. So I do think there's value to sort of circling back around and going and learning K framework together and trying to implement the pi calculus and rho calculus and all of that in K framework, and then from there maybe implement some pieces of Rholang in K framework so that we can understand the K framework definition and how it works when it comes out. But if anyone has thoughts on that, or is anyone interested in that?
I think it sounds awesome. I got excited about it, especially once you said that they were going to do the future specs that way. So I think it sounds good.
Cool.
Yeah, I'm also very interested. I started looking at it. I hadn't seen it before, but I am very interested.
Awesome. If anyone wants to do some homework and read ahead, you'll probably be ahead of me if you get to this. But I saw that Mike Stay actually uploaded some K framework examples that have like a minimal pi calculus in it. So in our chain Rholang source main K, apparently this was 7 months ago too. So here is like, all right, here's a minimal pi calculus written in the K framework. So we can definitely work to understand that. And oh, sorry, I'm not sharing my screen. Yeah. So in this path, rchain, Rholang, source, main, K, there's a whole bunch of K framework examples, and yeah, here's a pi calculus one. And if anyone finds good resources for learning K framework, I searched around a little bit and then found some like videos, which isn't my favorite way to learn, that sort of go over like defining lambda calculus and some other things in K framework and some other languages, but I haven't found like a really good text document introduction. So if anyone finds stuff, please send it my way. Okay, but any other comments or questions? Otherwise, I think we'll wrap it up here.
I have one quick question. Back on the console screen that you had a list or a tuple, and then you had get item index 0. How do we? I guess what I'm asking is, how do I know that this get item is available in Rholang?
Yeah, that's a good question. The answer is you don't right now. Yeah, these things will have to be documented somewhere, but they're not available right now. Yeah, I'm guessing there'll be certain like types that have different methods, and there'll be some sort of doc somewhere that has what's available, but there's nothing like that right now. And I don't think this isn't implemented in the current node right now, as far as I know. Yeah, thanks for that question.
Great session. Thank you.
Yeah, thanks for coming, everyone.
Thanks, Jake.
All right, see y'all later.
Thanks.